In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed through the cosmos. Each note, a shot of pure ether, struck the Einsteinian demons, dispelling them back into the void. The world was saved, not by a warrior, but by a musician, a scientist, a man with a flute. Remember, in this universe of...
All right, lads and ladettes, we are live.
Hello, and welcome to Ether Cosmology Research Night, or Reading and Research Night. Tonight we've got one shortish paper we're going to go through here. So we may be a little shorter tonight, but yeah. So we're going to read from the explanation of dynamical Biefield-Brown effect from the standpoint of ZPF field. We read about the Biefield-Brown effect a couple weeks ago, so if you want more on that, go check that one out. The quick disclaimer for Reading and Research Night is that this is not a presentation. This is not for entertainment. This is us just literally doing reading and research. And so if you want to come read with us, you can join us at discord.gg/ethercosmology. Or you can just go to ethercosmology.com and click on the little Discord icon. And yeah, we do this every Thursday night at 9 p.m. Eastern here on the Discord. So yeah, if you want to come read about physics with us, feel free to come join the server. And so yeah, without further ado, let's get into it.
Thank you, sir.
Did you want to start, Alan, or?
Yeah, I'll take a couple. All right, so
All
this
right,
is
cool.
this is the explanation of the dynamical BB effect from the standpoint of the 0-point fluctuation field, they call it. So here we go. So this is by Akaki Musha. The research group of the Honda R&D Institute observed the weight reduction by applying an alternate electric field to a capacitor. This phenomenon, which is called the dynamic Biefield-Brown effect, cannot be within the framework of conventional physics, can't be explained. From the standpoint of the ZPF field, this author tries to explain the phenomenon as an interaction between the vacuum electromagnetic 0-point field and the high potential electric field. By theoretical analysis, it is considered that the interaction of the 0-point vacuum fluctuations with the high field potential electric can induce a greater momentum for the dielectric material, which would produce a sufficient artificial gravity to propel space vehicles. Very cool. Introduction. This is a speculative paper on the phenomenon that might have space applications in the long term, provided it can be repeated, controlled, and in a full explanation found. In 1956, T.T. Brown presented a discovery known as the Biefield-Brown effect, abbreviated from henceforth as BB effect, that a sufficiently charged capacitor with dielectrics exhibited unidirectional thrust in the direction of the positive plate. In recent years, it was confirmed by the research group of the Honda R&D Institute that the weight reduction is observed by applying a high-intensity electric field to the capacitor, shown in citation 2. D.R. Buehler performed the experiments with high-voltage single and parallel plate electric capacitors, which indicated a net force acting on the capacitor's mass. In an experiment conducted by Woodward, transient mass shifts were also observed in the dielectric material by rapidly charging the high-energy capacitor in citation 4. Recently, it has been reported by Barbos and Miklos that they detected a force using a device which was a simple ping pong ball with a high voltage discharge element inside, in citation 5. From the experimental result, the device generated a propulsive force that was not due to air movement caused by the ion flow or ionic wind, contrary to the conventional explanation of the generated force due to the ion transfer between the plates of the capacitor. Shown in citation 6. M.B. King suggests in his book, in citation 7, that the electromagnetic fluctuations in the vacuum was the source of the BB effect, which generates a unidirectional thrust for the dielectric material under high potential electric fields. He considered that the slight coherence of the vacuum fluctuations due to the high potential electric field was caused by alterations in the inertial properties of the body with an ionic lattice of rapidly spinning atoms, but its mechanism was not fully explained. H.E. Puthoff proposed in his articles in citation 8 that the gravity from this form of a long-range van der Waals force associated with the rapid motion of elementary particles, quotation zitter, blah, blah, blah. In
Hey, Alan,
response,
sorry to interrupt.
Yeah.
Is your stream still going?
Yeah.
Okay, I gotta report that your stream was done, but okay, my bad.
Oh, is it? Oh, yeah, well, 1 second.
Sorry for
Actually,
the interruption, everybody.
You actually don't know. Give me 1 second.
And you are showing your window, by the way.
Yep. Thank you,
Oh, it
sir.
looks like you're up.
Looks solid to me.
Okay. Yeah, sorry, my bad. My bad.
You're good. You're good. All right. So Hufflepuff
You're
proposed
definitely
in
on.
his
Sorry.
yeah, okay. All good. 0-point fluctuations. He suggested that if one could somehow modify the vacuum medium, then the mass of the particles or object would change according to the 0-point field theory in citation 9. By using the theory of the 0-point field or 0-point fluctuation field in this paper, this author tries to show that the impulse electric field applied to the dielectric material may produce a sufficient artificial gravity to propel a spacecraft. Section 2, the Honda experiment applying the electric field to the capacitor. From the 1st of February until the 1st of March in 1996, the research group of the Honda R&D Institute conducted experiments to verify the BB effect with the improved experimental device, which rejected the influence of corona discharge and electric wind around the capacitor by setting the capacitor in insulator oil contained within a metallic vessel, as shown in Figure 1. The capacitor used in the experiment was a singular plate made of high permeativity dielectric glass with a thickness of T equals 1 millimeter, with a diameter of D equals 170 millimeters, and a weight of 62 grams. The electric balance used for the experiment had a resolution of 1 milligram. They conducted the experiments for the two cases, DC 18 kilovolts and AC 8 kilovolts pulses, supplied the capacitor by the experimental setup as shown in Figure 2. The circuit diagram for generating the AC pulses is shown in Figure 3. The high AC voltage was supplied to the capacitor through the ignition coil to produce the rectangular pulse with a repetition of 50 hertz. After amplifying the AC pulse by the ignition coil, the impulse electric field was applied to the capacitor through the diode by changing the polarity to produce a minus bias and a plus bias voltage to the capacitor as shown in this figure. The experimental results measured by the Honda Research Group are shown in Figure 4, and Figure DC1 and Figure DC2 are, we'll go ahead and look at the setup here. Right. All right. Let's see. Someone's hot micing a little bit. Is where the DC1 and DC2 are for the cases of DC 18 kilovolts and pulse 1, and pulse 2 are for cases of AC 8 kilovolt pulses, where the horizontal lines for this date of the experiment are the vertical lines for the change of the capacitor's weight. From experimental results, it was found that the case of AC pulses exhibit a higher reduction in the weight than in the case of the DC exposures. The ratio of them becomes delta W prime over delta W equals 2.77 plus or minus 0.87, where delta W prime is the weight reduction for the AC pulse and delta W is for the DC exposure. Maximum weight reductions measured at the experiment by applying the AC pulses was 1.92 grams, which is about 3% of its own weight of the capacitor used in the experiment. Supposing that the weight reduction of the capacitor is responsible for the force generated by ionic transfer of the momentum, it can be estimated by the equation given by equation 1 here. So we have delta M is the square of 2 m naught times v naught over q times I over g naught. And then here we have our weight reduction according to the respective pulses or currents, where m naught is the mass of the carrier and the charge of the medium, q is the charge of the carrier, g naught is the gravity acceleration on Earth, v naught is the voltage applied, and I is the current density given by I equals 2 pi fc v naught. C is the capacity, F is the frequency of applied voltage. By introducing the experimental values for the AC cases into equation 1, where C equals 1,682 PF, I don't know what that is. V naught equals 8
Those are
kilo.
picofarad. It's a very small capacitance.
Got you. So picofarad. So V naught equals 8 kilovolts, and the frequency is 50 hertz. The mass reduction due to the ionic winds becomes delta M equals 1.3 times 10 to the minus 3 grams, which is negligible small compared to the experimental results. Following formula can be obtained by the electrogravitic effect induced on the dielectric material from the weak field approximations from Einstein's general relativity theory, given by citation 11. Here's the equation for that, and equation 2, where E is the magnitude of the electric field impressed on the capacitor, Z is the number of electrons circulating around the atomic nucleus, epsilon is the permeativity of the dielectric material, epsilon sub r is the specific inductive capacity of the dielectric material, and G is the gravitational constant. E. Ivanov of the Institute of Nuclear Research and Nuclear Energy in Bulgaria also found a similar equation reduction from Well and I don't know that guy's name, solutions of general relativity theory, which is equivalent to this author's equation shown in the appendix. From the weight reduction of the capacitor under the impressed electric field given by delta W can be estimated by equation 3, where we have delta M equals minus M times, or the dot product of E sub G equals 8.62 times 10 to the minus 11 Z over the square of epsilon r times EM, where M is the mass of the capacitor. By introducing the values of the experiment, Z equals 10, epsilon equals 10, the big M equals 62 grams, into equation 3, we obtain the delta W of 0.31 grams for the DC 18 kilovolts. Exposures which is close to delta W equals 0.29 plus or minus 17 grams obtained from the experiment, but we have delta W equals 0.14 grams for the AC 8 kilovolt pulses, which is the number lower than the experimental result of delta W prime equals 0.88 plus or minus 0.63 grams. Thus, it is thought that the BB effect for the AC 8 kilovolt pulses might be due to another mechanism other than ionic transfer momentum of weight reduction generated by the electrogravitic effect. If anyone would like to popcorn.
Sure. Is Toby not there? Go for it.
3, mass shift by the external electromagnetic field. According to the quantum electrodynamics, the quantum vacuum is filled with the electromagnetic fluctuations of the zero-point field, SPF, or ZPF. Haish, Rueda, and Puthoff pointed out in their paper, citation 12, that the formula on the ZPF determined inertial mass is remarkably similar to the mass shift derived from the quantum theory. Under the intense electromagnetic field, it has been predicted that the electron experiences an increase in its rest mass under an intense electromagnetic field. Citation 13. The analogical formula with respect to the mass shift of the electron under the intense electromagnetic field was discovered by P. Milani, shown as follows, and that's in citation 12. Let H sub A be the electrodynamic Hamiltonian of the particle under high electromagnetic field. It has the form shown as H sub A equals E squared over 2m sub 0 C squared, being greater than, or what is that, a set of A squared being greater than A squared. And then where m sub 0 represents the rest mass of the elementary particle C is a light speed, E is a charge of the particle, and A is a vector potential of the electromagnetic field. The similar equation by using terms of the ZPF field was also proposed by Haish, Rueda, and Puthoff, shown as citation 12. And then here you have H prime sub A equaling E squared.
Planck's
H,
constant.
what is that? Got
Or Planck's reduced constant.
Thank you, sir.
Yeah, the reduced
Planck's
form. You see the little bar over the H? That's the reduced Planck's constant.
So E squared times Planck's constant over 2 pi r m naught times c speed of light cubed times omega squared sub the speed of light. Is that correct? Wow. Where Planck's constant is a Planck constant divided by 2 pi, and omega sub c is a cutoff frequency of ZPF spectrum in the vacuum. Assuming that electrodynamic Hamiltonians shown in equations 4 and 5 are identical with each other, then we have delta H sub A equaling delta H prime sub A over the dielectric material under impressed electric field as shown in figure 5. We suppose that the cutoff frequency of the vacuum is shifted as omega c equaling omega naught plus delta omega, okay, when the electromagnetic field is impressed to the dielectric material. Delta H prime sub A becomes delta H prime sub A. There you go, equation 6.
Yep.
Where omega naught is the Planck frequency given by omega naught equaling the square root of c to the power 5, ratio to the Planck constant times big G, approximately equaling 3 times 10 to the 43 hertz, as shown in
freaking fast.
Freaking fast. And that must be why you're square rooting. It's always looks real promising when you're.
Seems a little bogus to me, but let's keep going.
You're going to the 5th power, that you're square rooting, and you can squeeze some crap in there too, huh? Yeah, that's. As shown in figure 5, H sub A equaling 0 at the initial state, then we obtain the formula given by. So let's see. Let's look at that little diagram there. So we have no electric field, A equals 0, A equals 0, and the impressed electric field. So that's just assuming that you're using the same A material essentially, and then you'd have you can take the delta with the impressed electric field, and then you're able to pull out the full change in state from that. And that's what we're running these equations on. that's what this math is all surrounding, I guess, is the way to put it. If you go back to like, what was it, equation 4 or so. So scroll down more. So yeah, equation 7 there. Delta omega is approximately equal to pi c, yada yada. Equation 7. According to the gravitational theory proposed by Haish, Ueda, and Puthoff in citation 14, we can suppose that the inertial mass of elementary particles induced by ZPF field can be given by mass equals, what is that guy?
So
Hangman.
Christoph symbol?
Looks like a big tau.
Kirchhoff symbol, you say?
Yep.
Okay. So Kirchhoff symbol times Planck's constant times omega squared sub c over 2 pi c squared, where this guy is the radiation reaction damping constant. Aha. Defining the interaction of charged elementary particles with electromagnetic radiation field. Okay. From which we have delta m over m equals 2 delta omega c or sub c over omega sub c, which equals pi c over the Planck constant times omega squared sub 0 or not, omega squared not, and then a squared. What is that, a set of a squared, or what is that, like pertaining to a squared?
Never heard of it. But
Weren't they just calling that an A vector potential a minute ago? Yeah, it's directly across from it in the other column below 4.
That.
So this Christoph symbol, my boy Rolando Tilt in the chat said that the hangman is also, you can call it gamma, and it's used for rotation.
Okay. Cool. Excellent. For the dipole field generated by the variance of electric charge, as shown in figure 6, the vector potential of the electromagnetic field becomes, as shown in citation 15, A equals 1 over, is that? Okay,
4
so
pi
it's 1
epsilon
over
naught
4
c
pi
squared.
epsilon naught c squared times p dot times t minus r over c over r. And then that's going to approximately equal 1 over 4 pi epsilon naught c squared times p dot times, or p dot of t over r, where p is a dipole momentum, or p dot is a dipole momentum given by p equaling qd, q charge of particles, d displacement of the charge. So it's the charge and the displacement. If we let pt equal p naught sine omega t, p naught equals ned, then we have equation 11. And in this equation, n is a number of charges per unit volume, and d is given by equation 12 here, which we have d equals e over m times e over omega squared sub e minus omega squared, where e is an alternating electric field and omega e is a resonant angular frequency given by this equation. We have omega e equaling the square root of z times e squared over alpha sub e m, or what is that, mu, nu?
Looks like an M to me. Talking about this.
Okay. Cool.
Also,
alpha e.
one more quick note on
What?
On the mysterious A over here. My boy says
Yes.
that it's an indication that you can use that you have a Lagrangian frame. Not sure what that means, but
Oh,
he's
okay. Well,
yeah.
thank you very much we always appreciate learning more math. So thank you.
Yeah. He said whenever you see A, it's just something allowing you to have a Lagrangian frame.
Okay. Sweet. Wow. The breadth of knowledge widens. So we go back up. Let's look at figure 6 here. Cloud of
the old
electrons.
electron cloud. Nice.
Yeah, nice.
Q representing charge in the center, it having a radiative outward force, giving Yeah. Put across an electric field, all, shifting it out of the dotted line to the cloud.
Cool. Thank you, sir. So from the above equations, we obtain the following equation for the charged sphere with a radius of r. And there you go. Boom. The answer is 2. I just figured it out in my head.
Oh, nice.
As the
little quick math for you.
yeah, there you go. It's 2. If anyone was trying to
Stunning calculation.
Ooh,
Who needs quantum computing? Well, we got Toby.
Yeah.
As the energy dissipation can be incorporated into the analysis by replacing real quantities with complex ones, as shown with omega to omega times 1 plus in over 2, where nu is a damping factor, equation 13 becomes equation 14. For the impulsive electric field, which has a wide frequency range spectrum of omega sub 2 minus omega sub 1, is large compared to the width of the resonance, and the following integration over frequencies across the resonance yields equation 15. From which we obtain the ratio of the mass shift of the dielectric material versus its rest mass under the impulsive electromagnetic field given by equation 16. Wow. Assuming that nu equals 2e squared over 3mc squared, that equals the Abraham-Lorentz damping constant of equation 16, and then we have equation 17. Delta m over m equals 3 pi over 16 times the rest of equation 17 there.
Nice.
E squared, yeah. Where n is a number of electrons per unit volume in a space. Let's go, yeah. Including the dielectric material, and r is a radius of the electron cloud, and E is a magnitude of the impulsive electric field. Possibility to produce artificial gravity by electromagnetic field. Combining equations 2 and 17, the force produced by the electrogravitic field, E sub G, becomes equation 18 here, where, let's see, okay, where m is a mass of the dielectric material. From this equation, it is seen that the electrogravitic effect generated for the dielectric material can be amplified by the impulsive electric field, okay, as observed by the Honda experiment, which also supports the Brown experiment, where he observed a large thrust associated with a spark between electrodes for the disk structure as shown in figure 7 from citation 7. Or from, sorry, equation 7. Citation 7, my bad. From equation 18, the new factors which increase the force for the dielectric material are increase the magnitude of an electric field impressed to the dielectric material, increase the number of electrons per unit volume in a space including the dielectric material, increase the radius of the electron cloud in a space including the dielectric material. As the mass shift of the dielectric material under the electrogravitic satisfies delta W equaling negative m times E sub G prime, then we have equation 19, where delta W prime and delta W are weight shifts observed at the Honda experiment for AC pulses in DC exposures, and E prime and E are amplitudes of the AC and the DC electric fields impressed to the capacitor, respectively. By introducing values, E equals 18 times 10 to the 6th power VM, volt.
That's volts per meter. Yeah.
Thank you, sir. Volts per meter. E prime equals 8 times 10 to the 6th volts per meter. And then R equals 0.5 millimeters. Omega E equals 10 to the 15 radians per second, and m equals 9.11 times 10 to the negative 31 kilograms for the electron's mass. Into equation 19, we obtain delta W prime over delta W, which equals 3.2. Oh, I was 1.2 off. When we
Dude, you were
suppose
so close.
So close. An order of magnitude close. Wow.
right. When we suppose n equals 10 to the 26, which is lower than the critical plasma density that equals n to the n equals 10 to the 28th, and that's, you can see that in citation 17. This is close to the experimental result obtained by the Honda Research Group, and hence it can be considered that the electric discharge between plates, which has a wide range spectrum, produces a large force under the impulsive high potential electric field. As the mass shift predicted by equation 17 is dependent on the external electric field, the variance of weight reduction observed at the experiment might be due to the secondary electrostatic effect related to related global electric field. The secondary electrostatic effect related global electric field, as reported by G.V. Stephenson in citation 18, the influence of which cannot be totally rejected by the electromagnetic shielding. You don't say. From the equation for the momentum given by F equals dp over dt, the momentum produced by the electrogravitic field becomes, next page, please. Citation 20, or sorry, equation 20. When we let delta t equal L over V sub d prime, or is that what that is? Or no, sub d, sub d prime, where L is a separation between electrodes and V sub d is a drift velocity of electrons, the momentum produced by the impulsive electric field becomes equation 21. From equation 21, the velocity, sorry, I'm kind of looking at equation 21. The velocity of the disk structure in figure 7. Can you scroll up a little bit there? Let's take a little peeky-boo at figure 7, maybe. So the velocity for the disk structure in figure 7 can be assumed by V equals P field over M prime, and M prime is the total mass of the spacecraft, as shown in figure 8. Okay. Well, we suppose Z equals 10, epsilon R equals 10, L equals a meter, and R equals a meter, and omega E equals 10 to the 15 radians per second, and M equals 9.11 times 10 to the negative 31 kilograms, and tiny, N equals 10 to the 26, V sub D equals 10 to the 8 meters per second. The value for the vacuum arc in citation 19. And M over M prime is approximately equal to 1.1 N. This figure, the horizontal line, is for the voltage applied to electrodes, and the vertical line is for the velocity, both in a logarithmic scale, from which it can be seen that the electrogravitic craft, using the Biefield-Brown effect, might attain the velocity to reach 5.3 kilometers per second when impressed 1 gigavolt to the electrodes. Hence, it is considered that this electrogravitic system can be used for space travel instead of the chemical rockets when either of the following factors is increased. 1, voltage impressed to the dielectric material. Okay. 2, separation between electrodes. 3, number of electrons per unit volume in a space, including the dielectric material. 4, radius of the electron cloud. Very, very interesting. Conclusion.
I see one other thing they should have on that list, and it's according to some other things I want to cite in this paper when you're done with the conclusion. Yeah, so keep that in mind, this little list here.
Cool. From the theoretical analysis by the zero-point field theory, it is thought that the origin of the dynamical Biefield-Brown effect might be attributed to the interaction between zero-point vacuum fluctuations and high potential electric field applied to the capacitor. The theoretical analysis result suggests that the impulsive electric field applied to the dielectric material may produce a sufficient artificial gravity to attain velocities comparable to chemical rockets. Very interesting. So yeah, that's end of that one. I don't know if Alan stepped away maybe for a second.
Just got back.
Cool. So yeah, interesting stuff. Yeah, did you have some thoughts there, Stun?
Yeah, right there just before the conclusion, he was talking about his list of things that would have to be improved on in order to increase the factors. Voltage, separation between the electrodes is what I take to mean the distance between the plates themselves, as then they want to decrease that and improve the insulational power of the dielectric between them so that you can still apply higher voltages at smaller plate gaps, if you know what I mean. That they are closer and closer together with higher and higher voltages applied to them is the goal. Really what they're looking at. But what he said on the previous page in the top right at the beginning of section 4, right after equation 18, he said, from this equation it is seen that the electrogravitic effect generated for the material can be amplified by the impulsive electric field. No, actually that's, yeah, there it is. It's in the second part of that, which also supports the Brown experiment, where he observed a large thrust associated with a spark between the electrodes for the disk structure shown in figure 7. So he's actually giving himself away here and never mentioning it again. That when we look at how this thing is constructed, he talks about the dielectric material that is connected to the plates themselves, as in typically copper wire or silver wire, if you want to reduce the resistivity there as much as you can, so that you can increase the rate at which it can charge and discharge itself as a capacitive plate, especially in the case of the AC scenario. Well, what he's pointing out here by saying that there's a large thrust associated with a spark is this is again catastrophic failure between the two plates where the charge exceeds the rating of the insulation between them. And it is catastrophically resolving its own charge within itself straight to the ground plate instead of through the circuitry out back through the wires that are connecting the plates to the rest of the circuit. Do you guys catch me on what I'm saying there? Or did I just lose everybody?
Kind of followed.
Okay, so the thing is that the way that a resonant tank circuit is put together, say between a capacitor and a coil, it's all about how fast the capacitor can be charged and discharge naturally as a point of its own physics, its own internal physics, its own dimensions and gapping and that kind of thing, as well as the resistance of the wires that are charging it and discharging it. That current takes a certain amount of time to travel through a conduit of a certain resistive character, of a certain cross-sectional area. You know what I mean? That the charge can only blow through that solid so fast. What he's pointing out here is that when it is discharging via spark and not out through the wires, that it's actually discharging in a far quicker fashion probably a couple of order of magnitude faster, something you would want to see on the scope. And as a result, you're getting a far larger thrust out of it in terms of its motion.
Okay.
Does that register?
Yes.
Like he speaks it right there, and then he never mentions it again. I just find that really interesting. He didn't even put it on his list.
Yeah. That's super interesting too.
Oh, good.
That's pretty crucial to how the whole thing would be mechanistically cause propulsion, right? I mean,
It's what he's been talking about since the beginning, was the super fast
what are
oscillation they're supposed to be using. But I find it so ironic that they're only hitting this thing with 50 hertz. And that's how we're noticing this difference, that the discharge rate at 50 hertz is charging and discharging in both polarities at 100 times per second, right? Well, you know, the spark's doing it way faster than 100th of a second. We're talking a couple of nanoseconds or even, you know, picoseconds, tens or hundreds of them, maybe. That would be my guess in terms of how long it would take that charge to partially resolve as much as it can through a spark gap until finally there isn't enough charge left in that upper plate to maintain that bridge of the gap, so to speak, through the spark itself, and then it stops sparking. You know what I mean? That length of time on to off of the spark itself is incredibly short compared to what they're doing with an AC pulse at 50 hertz or a square wave on and off at the same kind of order of magnitude of frequency. To me, that is so physically mismatched. I'm really surprised it got past these guys when they're so balls deep into the formulae, but they missed that on the practical side, the first order practical side. You know what I mean?
Sounds about right. I mean, it's pretty par for the course. But I appreciate the insight. That's
surely. It looks like we had a lot of mathematicians on the team and not very many practical engineers.
Anyone else? Any thoughts, questions? Stone, if you have anything else you wanted to mention from the paper?
No, that was a good first reflection, I think, on the total content.
It was pretty interesting. A number of interesting concepts kind of glossed over in there. Well, cool. I don't really have anything else. Anyone else have anything? We could really just kind of wrap things up here at this point, probably. If no one else has any final thoughts or questions or anything. All right.
Yeah, we can go
Well,
ahead
cool.
and wrap.
Thanks, everyone. What's up?
I said, yeah, we can go ahead and wrap. But before
Cool.
we do, Lily, do you have any testimonials for us or Galatrax, perhaps?
Oh, yes, I do. I do have a testimonial. Oh, yeah. So, a couple years back, this fellow moved in across the street. His name is Lucas. And, I was trying to be neighborly. And so I baked these amazing cookies with fair trade organic chocolate chips and, with organic heirloom spelt flour and a kamut flour and unrefined sugar. I mean, just the best, tastiest, healthy cookies. And I took him over just to be neighborly. And so then he opens his door and then he says, I don't eat sweet stuff. And then he just slammed the door in my face. I was like, oh, okay. And so a couple of weeks later, I thought, okay, I'll just take something savory. So I made these amazing spinach pies with feta cheese and pine nuts and organic phyllo dough and beautiful mushrooms in there. I mean, so good. My spinach pies are the best. Anyways, I took him over there and then he opens the door and then he just like grabs the little plate, with the spinach pies on it. And he says, okay, thanks. And he rolls his eyes and he slams the door. And I was like, okay. I figured, well, he's just, not very neighborly. So anyways, long story short, it was springtime, in a few weeks. And so I was out there in the front yard and I was cutting some beautiful peonies to take inside. And what I forgot was just that morning, well, actually, like a few days before, I had received the brushtail coffee for the very first time. So that morning when I was cutting the peonies, I had just drunk some coffee, and then I had come outside and I was humming a tune, cutting my little peonies, and then I see him. He opens the door and he runs across the street, and then he says, "Oh, good morning, Liliana. What are you doing?" And I said, "Oh, I'm cutting some flowers to take inside." Anyways, long story short, this guy, he's like a professional model, so I guess like ladies would find him handsome or sexy or hot or whatever, but like I don't care about all that crap. And I would have treated him the same if he was a little old lady, right? And so I said, okay. And then so he said, "You like flowers?" And I said, "Yeah." So he quickly whips out his phone from his pocket and he orders a bunch of flowers to be sent to me, like tuberose and lilies and really expensive bouquet of flowers. Anyway, long story short, he was running over across the street, trying to be all friendly with me. And always in the morning, because I usually drink coffee and then I go out to the front yard, to just check on all the flowers and this and that. And I'm telling you, I think the brushtail coffee just changed my pheromonal profile. And this guy, so finally he knocked on my door one day and he's like, "Hey, you want to go on a date?" And I said, "Buddy, take a number, get in line." And then I rolled my eyes and slammed the door on him. That's my brushtail coffee story for today. My testimonial.
Wow.
So you're
Wow,
telling
the
me?
dynamic totally changed.
Wow.
Yeah, it will change the pheromones and attract people to you.
Well, I can't verify that, but a claim is a claim, and that's a very interesting one. And by the way, if you want some brushtail coffee, you can go to brushtail.coffee or brushtailcoffee.com and order there. I just got in some new Ethiopia Yirgacheffe, and I also have a new Mexican coffee that I will be listing. I'll have to do that like tonight. So yeah, go check that out. Yeah, what's that?
Yeah, do you do any international shipping to Czechoslovakia?
No, I don't.
You
But
probably should figure that out.
maybe I should. The Czech Republic, Slovakia, Czechoslovakia.
All right, Riggs, here's
Yeah.
the thing. We do international shipping, but not what you would call legally or above board. We may or may not have coffee smugglers.
Yeah, may or may not.
Mules.
Yes, coffee
We
mules.
sneak it in bags of drugs, and we pretend like we're smuggling drugs, but we're really smuggling coffee. That's how we get the coffee over the borders.
Do you remember that time the
That's
ADF
what-
raided your shipping container and they were looking for drugs and all they found was delicious fresh roasted coffee with a
Well,
roasted date on it?
But that started.
That's
the
how they
Cold War.
mask the smell. That's the success. You've got to put shitty coffee around it when you pack it in, so the dogs will smell the shitty coffee and they won't smell the good stuff and
That's
find yours.
brilliant. That's brilliant. Well, okay. Well, maybe we have some new tricks up our sleeve for shipping to the Czechoslovakia now. So yeah.
All right, we're starting
I
a
thought
coffee
coffee
cartel.
is a drug. Isn't coffee a drug?
I mean, I don't know how
Yeah.
you inject your brushtail coffee intravenously, but that's how I take it.
Yeah, I think it technically is. Caffeine definitely technically is. So yeah. There you go.
You're on the schedule.
That's right. Yeah, it's funny. I get text messages from some people and they're like asking for descriptions, like, "Oh, it kind of smells like this, and it's got a flavor like this," and it definitely starts to feel like I'm a drug dealer sometimes. Definitely.
Oh, the Ethiopian one
got
right
the
now. I'm
stuff.
really enjoying it, Toby. I gotta order some more.
Hey, Dave, I got the stuff. Let me in.
Exactly.
You got that Ethiopian fresh blend sticky icky?
Yeah, hook you up. Just go to the web page, order some quote unquote, order some whatever, and then I'll send you what you really want.
Nice.
No stems, no seeds, no beaks.
No beaks, no penguin beaks.
Take care of it, boys.
But yeah, for real, check it out, brushtail.coffee. I really do roast the coffee myself on my grill. But yeah, I think we can wrap it up then, unless there's any other final things. Oh, did you want to plug tomorrow night or
Yep.
whatever?
Yes, sir. So tomorrow night, Flat Earth Fridays, episode 113. And then on Tuesday, 8 p.m., Shane will be doing a presentation on the nature of electricity. So hopefully we'll get into that.
Oh, goody.
And that's all we
Very
got
cool.
coming up.
Very, very cool. Awesome. Well, thanks everyone for being here and reading with us. Take care, everybody.